Here we go. Lesson 1-5. Last lesson of the chapter. It is. Using formulas. All right, let's talk about a few of these. What would our formula now? We're finding the area of these objects. What's the formula for a square? Michael, find the area of a square. Huna, what? 4 times 4? Masa. Okay, some of you are familiar with base times height. Same thing would be length times width. Okay, either one of those. What other shapes does that formula work for? Nobody knows. A rectangle. Very good. Works for a rectangle. What else? Tyler? A parallelogram. That is correct. Okay. So length times width, base times height, either one of those is good for a square, a rectangle, and a parallelogram. That's correct. Okay, now these are all on your cheat sheet too under class resources, so that's good. All right, next one. What about a triangle? What would our formula be for a triangle? Zach? Oliver? Well, no, if it was base times height, then we would have put it up with the other 3 figures. Zach? No. Really? Formula for a triangle? Okay, so normally I think in elementary school they teach this one, base times height divided by 2, right? Isn't that the one they use? Yes or no? You don't remember? Okay. Base times height divided by 2. Maybe some of you are wondering why the divided by 2. Because if you take a rectangle, yes, and you divide it by 2, don't you have 2 triangles there? Uh-huh. All right. Now, there is another one for a triangle. There's another one that you may not be familiar with. Your parents may. Okay. The other one, this was not available when Mr. Fisher was a child, by the way. We took half of the base times the height. That's another one. Okay. So don't be confused if you see half of the base times the height. So far, so good? Okay. Do these formulas work for a right triangle? Yes, of course. It's a triangle. It's a triangle. Okay, nothing changes. Right triangle. All right. What other shape do we need? A trapezoid, yes. Bless you. Trapezoid. Trapezoid, anybody know? The height, base 1 plus base 2 divided by 2. It is. Okay, we can rewrite that to look like this because sometimes it's written like this as well. This is the same thing. Now, these are all on your cheat sheet, so don't worry. Panic, yes, yes. All right, everybody good with those? Right, again, this is nothing new. These are all on your cheat sheet. You're going to need to reference them, and that's a good thing. Okay, so we mentioned something about a formula. Anybody know what a formula is? Formula is an equation that tells how one variable is related to another. That's all that means. How variables oops. There we go. How variables are related to one another. That's all formula is. Do you multiply things together? Do you divide things? Do you add them? Do you subtract them? Okay, now in all honesty, this lesson is really easy because here's why. The formula is already going to be given to you, right? You're going to have your cheat sheet. Okay, all you do is you plug in the numbers and you add, subtract, multiply, divide. That's it. Okay? All right, here we go. My shapes. All right, let's start off easy. I have 4 meters by 4 meters. Okay, there's my shape. They're going to label the shape. If they're asking you to use a formula to find the area of the figure, the first thing that I would do is write the formula. By writing the formula, all you have to do is plug in the numbers where they go and follow the order of operations. 4 times 4. You could write 4 parentheses 4. The area of our square is 16 meters. Now, is that the correct label if we're finding the area of something? Yes or no? Do you know? What's that? Okay. You know about this little 2 thingy? Yes or no? Okay. If you're finding the area of something, you need to have it squared. You're squaring the units. Listen carefully. You're squaring the units, not the number. that make sense? Okay. Look here. Let's talk about something here real quick. 16 meters. If I was to write that, what does that look like in the metric world? Anybody know? Okay, 16 meters looks like a straight line. That's something that we call one-dimensional. Something that's one-dimensional is a line. Now, all of a sudden, if you take 16 meters and square it, now that means that you have a two-dimensional figure. You have the length and you have the width of something. That's why the little 2 is there, because you're multiplying two numbers together. Does that make sense? 16 meters cubed. What does that mean? What does that look like, Zach? That is three-dimensional. That looks like this. You now have the length, the width, and what gives it its three-dimensional shape is the height. So, the reason I'm showing you this is why you are going to have to label correctly. You have to know your dimensions. Something that is one-dimensional is just a line. Hopefully from that screen right there, you can see that labeling is very, very important. If you label something two dimensions, right, meters squared, and you're just talking about the distance from a wall to a wall, that's a straight line. That's the wrong label. Everybody okay with those? Okay. What happens? Let's talk about this. They give you a square. They do that. And they only give you one dimension. Hopefully you're asking yourself, what are the measurements of the other side? Michael, how do you know that they're 5 centimeters? How do you know? You're right. That's what I'm getting at. How do you know? Tyler. Okay, not only does it have a right sign, in the math world, if they give you only one dimension, all of the other sides are the same. This is what we call a perfect square. Okay. So no need to panic. If they only give you one, you're like, oh my gosh, what do I do? What do I do? All of the sides are the same. Okay. And they will do this occasionally. Given one measurement, you have a perfect square. All the other sides are the same length. Okay, we good? All right, next. Okay, triangle. This is the most common missed shape. I will tell you why in a minute. Okay, normally they represent the height by a dotted line. That usually is the height of something. Okay, so we're going to say that the height is 9 inches. And we're going to say the base is 24 inches. Okay. Area is equal to what? Our triangle. What do you got in your notes? Okay, Han. All right, very good. So again, write the formula. This is the way I do it. It's just a recommendation. It's so much easier. Okay. The base is 24. The height is 9. Again, you can use parentheses. You can use the raised dot. Personally, I get in the habit of using parentheses because that's where we're going. Okay. Divided by 2. Area is equal to 216 divided by 2. Area is equal to oops, I goofed. 108 inches squared. Now, let's take a look at our answer. 108. What do you think the most common missed step on triangles are? This, I guarantee somebody's going to do this. Tyler, you forget to divide by 2. Most common mistake. I'm just telling you up front. It truly is the most common mistake. What if you do what? Okay, well, what happens if you can't divide it by 2 evenly? What kind of a number do you get? A decimal number. Yeah, it happens. Trust me, it's going to happen. Okay? You're allowed to have decimal answers. If the number is not even, you are going to get a 0.5. You're going to get a decimal answer. Okay? And then you're going to have to label correctly. So far, so good. Everybody good? Okay. Last one. Trapezoid. Okay. And then they're going to have one of these because they got to show you what the height is. Okay. So this is going to be 4 feet. The height is going to be 7 feet. The base is going to be 10 feet. Okay. If you go back to the formula, again, write it down. H multiplied by base 1 plus base 2 divided by 2. Okay, so if we plug in now base 1 and base 2, what do you think the bases are? Okay, on? Yeah, the top and the bottom. Now, the nice part about this is, does it matter which one is base 1 and base 2? No, you're adding them together anyway. Right? It truly does not matter. Okay, this can be base 1. This can be base 2. You can have them backwards. 4 feet can be base 2. 10 feet can be base 1. Doesn't matter. Okay, so in our formula over here, we plug in the height. 7, 4 plus 10 divided by 2. Okay, 7 times 14 divided by 2. Area is equal to 98 divided by 2. And we arrive at area is equal to 49 feet squared. The label is important here. Okay, again, you're just plugging in numbers in the formula and solving using the order of operation. It's truly that simple. Okay, we don't need to do a rectangle because that's a square. Parallelogram, that's a square. It's the same formula, right? Okay, we're not using circles right now. Good question, but we're not using circles. That's chapter 6. A rhombus. Emma asked about a rhombus. What's a rhombus? It's a square. All sides are the same. Why do you think they call it a baseball diamond? It's a square. It's just tilted. Okay, lesson 1.5, using formulas to solve problems. Okay, one more. Last one. What happens if you have something that looks like, if you have something that looks like this? You're going to want to write this one down. Hint, hint. Quiz question. Bless you. Bless you. All right. What is in the red is the shaded region. Okay, so that simply looks like you have a piece of paper and you have something sitting on top of it. Okay, so here's what it looks like. I'm showing you. You got to look back here. You got a piece of paper and we're putting something on top of it. That's a little square, right? And we're asking you to find the shaded region, what's around it. Okay? Just so you have a visual. Does that make sense? All right, so first plan of attack. What are you going to find? Of what? Okay, the area of what square? The big square, right? So again, that's length times width. Okay, so that would be 6 parentheses x plus 4, right? You agree? Okay, so then we get 6x plus 24. Solving it, and I'll put big square because that's what it is. You agree with that? Okay, now what do we do for the smaller square? If we're trying to find the red, how do we find the area of the small square? Okay, so what is x times x? Anybody know? Okay, lesson in variables. When you add two variables, what do you get? What do you get? How do you simplify x plus x? Yes, you get 2x. When you add them, you get 2x. Are we adding them up in the small square? No, we are multiplying them. When you multiply two x's, what do you get? You get x squared. Might want to write that down. Not sure we know that. So our small square is x times x to get our area of x squared. Now, it's sitting on top of that big piece of paper. So what are we going to do mathematically? Anybody know? Well, if I want to find the red area, I'm going to take my big square, yes, which is 6x plus 24, and subtract the small square out. Because the small square is sitting on top of that piece of paper. Does that make sense? You're subtracting it out, right? Because it's, look here, it's covered up. So you've got to subtract. You can't see underneath. It's covering it up. So you've got to subtract that out, right? Because again, you only want to find the shaded part around it. Does that make sense? Okay, Tyler, do you have a question? Oh, okay. Everybody good? Hint, hint. You need to know how to do that. Okay. All right, that's lesson 1-5.